مرحبا بكم جميعا. المنصة العلمية لهيئة البحوث الزراعية بالتعاون مع نادي البحوث بكلية الغابات جامعة الخرطوم ومؤسسة الباحثين السودانيين في سلسلة بتاعت محاضرات عن تنمية خلفية البحث العلمي والابتكار للباحثين وصغار الباحثين وطلاب الدراسات العليا. والهدف هو معرفة المهارات بصورة عامة، وهي سلسلة مستمرة ابتدأت مجموعة من الطلاب المبتعثين ومجموعة من الباحثين السودانيين. المتقدم اليوم هو زينب، محاضر بجامعة إدغريد إثيوبيا، وهو طالب دكتوراه مرشح بالجامعة المجرية للعلوم الزراعية. محاضرة اليوم بتتكلم عن استخدام المينيتاب، وهي المحاضرة الثالثة. For those who speak English language, the lesson is going to be by English language, and sometimes we will try to translate for our colleagues. So it is a scientific platform. It's a scientific platform of Agricultural Research Corporation in collaboration with the Faculty of Forestry Research Club and the Sudanese Research Foundations. And this for improving the quality of the researcher and young researcher and high degree student. The objective to get comprehensive background about the research skills and how to use these skills to help yourself in writing your scientific programs, whether it is scientific article or your thesis degree. And Zainabu, he's a lecturer at University of Adiglit, Ethiopia, and he's a PhD candidate at University of Hungarian University of Agriculture and Life Science. The lecture today is going to be about using Minitab, one of the skills of statistical analysis. And this lecture is going to be recorded, and it is available for everyone to share it. And thank you so much. Very welcome, Zainabu. And for the college who's participating right now, you can raise your hand anytime if you didn't understand anything, because they aim how to get benefit from this lecture. So welcome, Zainabu, and the floor for you.
Okay. Thank you, Mohammed, for your introduction. So as Mohammed mentioned, today we will discuss about some statistical analysis of any research or thesis work using Minitab software. That may be an important thing. So with this, we will see some theoretical highlight, then we'll proceed more, we'll focus on the practical aspect. So at the first, we will see the overview of the Minitab software and its purpose, especially on the education and research, and the data management, data analysis, and their interpretation. We will see in both theoretical and practical way. So as introduction, nowadays there are a lot of statistical analysis tools you can use easily. You can access from internet. You can download and install in computer, but some of them they need some computer programming skill. But the advanced Excel spaces and Minitab softwares are relatively easy when compared to the MATLAB, Python, R. In case of user-friendly. So in this one, we'll focus on the Minitab. So the Minitab software is a powerful statistical software package, which is widely used for data analysis and quality improvement. It's also known as for its easy of use and comprehensive statistical tool, which is making it popular in manufacturing, research, and academia. So this software has three main features. The first one is about the key features, which is user-friendly interface. It has easy interface you can adopt easily. There are also comprehensive statistical tools, data visualization, quality improvement tools. And the second one is application. This software can be applied in quality improvement, especially in industry to enhance the quality of some process. If you need some optimization, so you can use the statistical analysis with the software. In education and research also is applied. Most some if you see in some published article, they use Minitab software for statistical analysis as the one supported tool. In manufacturing industry, the same. In healthcare also it's applied. So you can also learn from different type of sources. It can be available in online as tutorial, webinars, and user guideline. Even in its interface, there is an help title bar. So by entering in this help, so you can see the details. So the general overview of the interface looks like this one. So the title bar, as shown here, you can easily understand that these things are very important. In the file, you can get some save project work. If you have saved project work, you can open from this one. If you want again to save the current project work, you can save it with this one. And in data, there are data management tools here. You can split your data in different worksheets. You can subset your worksheet in different way. You can also sort. So you can here with this title bar, you will get the data management tools from this. And in a statistical title, you will get the basic statistical tool like basic descriptive statistics, regression, ANOVA, design of experts, quality tool. So there are multivariates. So you will get the details from this. In graph, you can see the visualization part. So when we see the purpose of this software in education and research, it is to very important tool, leverage its statistical tool and feature to gain insights from data, validate hypotheses, and support evidence-based decision making. So how? The first one, we have understanding of the data trend and pattern. So after you have collected your data, you can simply visualize how this data trends looks like using descriptive statistics and data visualization technique using the different plots in the graph title bar. Second one, you can test the hypothesis. You can use different type of hypothesis test in ANOVA, and t-test, like that, in confidence intervals. And the third one, the model and predicting outcome also, the correlation and the regression in different way, in different approach, you can also perform it with the software. The last one you can use for quality improvement. This is very important, I think, in industrial design of experiment. This is special for optimization of the process. You can use this using this software. So the first part, when we think about the statistical or data analysis, the first that comes to our mind is data management. This is a very important aspect. So after we collect the raw data, we have to make well-structured the data sets and avoiding the missing value, the outliers. So we have to manage these things with this data management aspect. Then after that, we will test the normality. This is very, very important for those, especially parametric variables. This is very important, the normality. So the normality should be tested with different testing methods. Then after the normality, if the normality is satisfied, so we can go to the further analysis because the last decision is based on the normality of our data. So from here we can describe about the descriptive statistics of about the variables, the ANOVA, analysis of variance, correlation, regression, we can perform easily. So in normality testing, this is very important. Why? The decision making is proceed after this analysis, after the analysis is based on this normality testing technique. So if the normality, the data is normal, so we have to go to the next procedure, and if it is not normal, we have to use different techniques or non-parametric testing technique we can use, or we have to transform the data using different type of techniques like logarithmic, square root, box-Cox transformation technique. We can apply this one. So in normality, this is the plot, the probability distribution plot, as is here, as it's seen. So from this graph, the 2 alpha beyond 2 alpha, the 95 confidence interval, we'll see about this. From here, this section is very important. So this, let's say this one is area 1, head 1, this is area 2, and this is area 3. So we'll talk about this 95 confidence interval. So if this goes to this direction, so the null hypothesis will be this. When the sample mean is close to the population mean to this direction, so this is very, the accuracy is very high. So we can proceed for the next analysis. With this testing technique, we can see the null hypothesis. We can put the data is coming from the normal distribution, or the alternative is the data is not normal distributed. So this rejection, if the p-value, the decision, the p-value should be greater than 0.05. Otherwise, it is not normally distributed. So we can test this one with different type of testing method. Let's say if you have our sample is between 30 and 50, so we can use Shapiro-Wilk test, normality test. This one we can use for the sample between 30 and 50. Or if the sample is greater than 50, we can apply this Kolmogorov testing. If we have large sample size, we have to proceed for skewness and kurtosis. This is very important for large sample group because these two are very sensitive to high number of sample groups. So as you showed here from the plot to show, if this is the population mean, if this is the 5%, this area 1, area 2, this is area 3. So our sample, this is our sample, this is the population mean. So when this sample is close to the mean, so A1 plus A2 would be much, much greater than A3. If this means the direction will be to this direction. So because area 1 plus area 2 plus area 3 is equal to 1. This is the probability distribution. This one. So if our sample mean is close to this one, so the area 1 here, so it will come to the acceptable level. This means the level of rejection will be small here. So that is very important to consider. So after we decide our data is normal, so we'll proceed to the descriptive statistics. We have to look at our trend, our data trend, how it looks like. So the first one we have to see is on the mean or in the accuracy. So mean is measure for the best estimator of the nominal data. This is the center of the gravity of the data, the gravity of the data. So mean, when we consider mean, we have to always think about the accuracy of our data, our observation. When we see about the standard deviation variance, we are thinking about, we are measuring about the noise or the scattering of the observation, how the observation scatter among themselves. This is the standard deviation, or which is directly related with the precision. So coefficient of variation is calculated by the standard deviation by the mean. So times 100, we can calculate the coefficient of variation. So if the standard deviation is very high, so the coefficient of variation will be high. So in this case, the process is very bad. So we will look at it, how the process looks like. The standard error, this is determined by the standard deviation over the root square of number of observation. We can determine this standard error calculated. So on the other one, to see in the figurative way, this is how it looks like. This is, let's say, the target mean. If the observation looks like this, so they are close each other. They are nice, they are precise, but they are far from the target mean. So we can call this one, they are highly precise but not accurate in this way. If the data looks like this one, if the data looks like this one, they are the distance from the targets to these are similar, but they have large difference across the observation. So they are okay, accurate, but not precise. We can call this one. Here, if we see this one, the target is here. They are scattered, looks like this one. Almost the distance across them is similar. So we can call they are okay, relatively accurate, but less precise. Here we will see the fourth one. They are far from with equal distance from the center, but with the same, they are accurate but less precise. They are far from each other. So this is what visualize to our data, how they are precise or accurate. So after this one, after we describe the descriptive statistics, we can go to the further analysis. Like if we wanted to compare some different groups, if we wanted to look the effect of the factor on some response variables, we can do the ANOVA. Here, ANOVA, analysis of variance. Here in the analysis of variance, the very important parameter is the between group and the within group. So this ANOVA mathematically is done by this variance here. So SSP, the sum square of the between group over degree of freedom. This the within group also the sum square of within group over the number of degree of freedom. So from this, F value can be calculated as the sum this MSB divided by MSW, mean square error of between group over the mean square error of within group. So from this, we can decide based on this if the calculated this one is greater than the F critical. This F critical can be determined with the F inverse of with the probability, degree of freedom 1, degree of freedom 2. We can get in Excel, we can access this function. So based on this, we can see the result of this critical, and the calculated is here. So the decision, the null hypothesis will be rejected if in this case. So this means at least one of the group are different from the others. So if we calculate the F with this formula, P value can be also calculated with the F square, the F distribution function using F distribution function with F score and degree of freedom 1, degree of freedom 2. We can easily get this P value, how it looks like. So this will be in practical, we will see later on. And the other one is after we compare different groups, if we wanted to proceed with further also to look some correlation between variables or regression for predicting model or outcome, we can see the correlation and the regression. Here, the difference between the correlation and the regression. So in the case of correlation, only we look only the relationship between two variables. So these variables may be correlated with the unknown reason without. So this simply describe how they are correlated or not. But in the case of regression, we'll see the response variable, how the direction, how the direction looks like, the magnitude in the direction we'll see in this regression model. So here, if we use with one predictor variable, it will be called simple regression model. If greater than this one predictor variable, we can call multiple regression model. So this regression model is computed like this with this linear equation, like y is equal to ax plus b, like that, plus error here. So this is the slope, this is the intercept, and this is the error. So this, from this, the t is independent for predictor variables, and this one is the response variable, and this is the error term. So we can, based on this one, we can look the prediction of between two variables, how they are predict each other. This we'll see later on how this looks like. Let's say this is the A and this is the B. So the relationship between them, when we see is the coefficient of determination is 98%. So with this formula, can we explain the B variable can be explained 98% with this formula, 0.689 times A plus this number will be equal each other. So this is the regression model. So this is now the theoretical aspect. If you have any question with this theoretical aspect, let me hear. Otherwise, we can proceed for the practical session.
So you can go for the practical if no one has questions.
Okay. Okay. So let me start with this simple data. Here, this is the mixing ratio. There are different mixing proportion, and this is the product strength value. So first, we have to look whether this data is normal or not. We'll see how it looks like. So first, we have to go to the stats, and then go to descriptive analysis. Here there is a normality test. So normality test, we can click here. So here it asks for the variable. So the variable is the strength. I put here. So the title, the normality test. Test. Here there are different type of normal tests. As I mentioned before, Shapiro, Kolmogorov, Anderson, something like that. Okay, we'll try that with the first one. I will okay here. Then the output will be displayed here. So this is the normality test. The figure looks like this is not normal. This is not normal distributed. This confirms that statistically the p-value is here less than 0.005. This means it is not, the data is not normally distributed, it says. So we have to now find out what is the reason for this. So we can see the reason from the basic statistics. We can see it with two techniques. The first one, we can directly check the outliers, or if in case there is an outlier, we can detect with this one. Here, the strength, I will put optional parameter, the mix, I put. Here there are different options. Okay, graphs, if we wanted to plot the outlier. So I will run OK. Here, it's highlighted map. This is the outlier, it says. Because of this, the normality is disturbed, you know, because of this value. So we can, now we have to see row number 16, which the strength value is 276. So this value is outlier. It says the software tell us this value is outlier. If we remove this outlier, the normal of the distribution will be normal. So otherwise, we have to explain what's the reason of this. In case if it has a significant meaning in your experimental work or in your data, you have to explain for this outlier. Otherwise, you have to remove out from this one. If we remove out, it will be normal. We'll see the row number 16, strength, yeah, number strength will, let's say we'll remove. Let's say, okay. This one, the last, if I remove.
It's not the
this,
last.
Yeah, this one. Now we can check again for the outlier. Okay. Now relatively it's okay. So on testing, we can again check. Anderson. Here. Now the data is normally distributed. You can see. Even the p-value, yeah. The p-value also tell us 0.907, which is greater than 0.05. So Now this is normally distributed. After this, we can proceed for the further analysis. So the first one is distributive analysis. We can go then strengths and then mix. From this, I would like to see, okay, the mean, standard deviation, variance, if you want a coefficient variation, skewness, kurtosis. These are not important. And number of missing. Okay, I will click OK. From graph, we need, okay, box plot. Here there is that. Now, this is the mean value, this is the standard deviation value, this is the variance value, coefficient variance. So we can now, across the mixing ratio, we can describe our result, the mean value of each. Here, how this is like here. So the from the second up to the fourth, it shows the trend is decreasing trend, you know, the strength of the material in proportion number 2, 3, and 4 show that, and a decreasing trend. So from this, we can explain more about the result. This one, figuratively, we can use in this way, or we can process in table for this one. So we can use one of them in our paper or our article. So after that, we can go to the analysis of variance. Let's say we can go with one way because the factor is 1, the mixing ratio. So we have one factor and one variable. So we can go to the one-way ANOVA. So from here, the mixing ratio is our factor. So we can select, go to the factor. And here the response variable is strength. And we can see also the comparison. Since our data is normal, we can use Turkey first, the comparison post-hoc test, you know. So we can Turkey, let's say, apply between group, how it looks like. As 95 confidence level, two-sided, it's okay. So if you wanna to use interval plot, it's okay. Then we run. Here, the very important result is this one. See, the ANOVA value, the p-value is 0.001, which means that there is the mixing ratio is very significantly affected the strength of the material. So from this, we can see how the difference looks like. The mixing ratio number 4 is different from the others. When we see the between groups, we can also see in the 95 confidence interval. This is the reference. So close to the reference, in a sense, there is no significant difference between the groups. When it's far from the reference vertical value, show that there is a significant difference between the groups. Here, between 2 and 1, between the mixing ratio 2 and 1, there is a significant difference. But when we see between 3 and 1, there is no significant difference because it's close to the 0 value, to the reference value. So based on this, we can see visually. If we were to report with interval, we can put also the mean and the standard deviation with interval. But here I will show you the mathematical aspect in Excel, how these are very important parameter. I will show you here. Let's say So MS between, this is between and this is within group. When this divided by this one, you will get the value of this. This means the formula that previously we see, you know, the one MS can be the mean square error can be calculated by the sum square error of the between groups divided by degree of freedom one. This. So it's mathematically right. We can also look this one divided by this one. You can get here. This is almost similar with no value. So from here, the F calculated value is this one divided by this one. Yeah, 12, 31, 12, 31. So from this, we can check the F critical, F inverse. You can click here, this one. Probability, our probability 95 confidence interval, so 0.05, the remaining one. Degree of freedom 1 is 3, and degree of freedom 2 is 11. So F critical is here. So 0 point. This one. Yeah, this value. Now here, we can see how the difference. This is much greater than this one. So the null hypothesis should be rejected. So the F distribution also, we can F distribution to the p-value. We can use this F distribution. So F score here, we have a degree of freedom 1, 3. We have degree of freedom 2, 11. We can see how it's like 0.00. This is counted. If you round this one, it's close to 0.001. This is mathematically how the statistics behind, you know, this one. We can see how the ANOVA looks like. The other one, we'll see with the other example here. Okay.
Can you share one example with 2 factors, for instance?
Yeah.
And also give a background about the experiment. For instance, everyone has to understand exactly, because now we understand it is just there are only 1 factors.
Yeah, one factor we did. This one was one
mix
factor.
and strings. So explain the experiment before like to make everyone understand what exactly.
Yes. Okay.
Yes.
Now here this, okay, for sheet number 2. Let's say this is the sample is, let's say, tomato. Tomato is stored at different temperature group, let's say 2, 10, 15, with different storage time. This storage time, the measurement for weight loss and firmness with for the interval, let's say. This is the data generated. So we have, from this, we have 2 factors and 2 variables, yeah? 2 factors
okay.
and 2 variables.
Sorry for contradict. Can you show us exactly what is the experiment? What is the design of the experiment? And what you want to measure exactly?
Yeah, this is the experiment.
Yes. So now we want to measure the tomato fruits.
Tomato, okay. So tomato is stored at a temperature of 2, 10, 50.
Yeah, all right, great.
And then for 12 days.
Okay, cool.
The weight loss and the firmness of the tomato is measured with 4-day interval. So this is the data from this experimental design. Now it's clear?
That is clear for me. For my side, it's clear. Just I want to.
So now, yeah,
to understand very well. Like, you know, they have to understand what is the main factors and what we need to measure.
So
exactly.
the main factor are time and temperature.
Yes, time and temperature. We have 3 levels of temperature and we have 4 levels of time.
Yes, yes.
All right.
That's better. So in this one, mixing only, it was a single factor with different levels, 3 levels, with single response variable. Here we'll see 2 factors, time and temperature, at different level for 2 variables, response variables. In this case, if these response variables are correlated, it's better we use MANOVA instead of ANOVA. If this in the same character, if they have good correlation. So from this we can, in statistical, we can use ANOVA here, general MANOVA. This, if you highlight this one, it says the model, the relationship between several response variables and common set of factors. It says. So we can use this one. So we can put the response variables here. And this is the model. Let's say time and temperature are the factors. So from this, we can see maybe option. No. So we can look the result. Here there are different methods, Wilkes and Pilas, Royce. So according to the Wilkes test, the p-value is less than 0.001. It says the lambda value is 0.397, which means that the 99.7% of the variables can be explained by temperature and time, they say. So it's significant. It shows that the temperature and time are significantly affected the weight loss and firmness. So we can proceed after this for single ANOVA or uni ANOVA to see the individual effect on each response variables. So we can use in this way, let's say this one. I see. This is only if you want to focus on time. So the time is the factor. If you see the response variable, look at the weight loss, we can see here. So this is the value. So from this, the time is significantly affect the weight loss. It's the F value is very high and the P value is very low. From this, I think when we see the decimal, it's 10 to the power of even 10, it's greater than 10 to the power of 16. So it's very highly significant, the effect of time on storage. So as storage time increase, the weight loss of the tomato increase. This means like that. So similarly for the other parameter can work like this. So that you have to use the report, the F value and P value in your document. The other one from this, we have to see whether they are correlated or not with this either figurative, this one. So time to firmness, it shows that, yeah, it shows that from 8 to 92, they have a strong positive correlation among the variables, you know. So the firmness and the time and the weight loss. So MANOVA is good to see the effect of the storage time, temperature on these variables. Okay, it's clear? If you have any question, I will. And the other one, we'll see the design of experiment.
Yes.
The design of an experiment. We can start from the design. Let's say first we can design the factorial design. We can create the factorial design here. So 2 level, 2 factor we can use. Okay, let's say 3 replication. The number of block 1. Okay, we can go to this one. Factors. Okay. Let's say something in extraction. Let's say optimization in extraction of some product. Let's say time is one of the factor, and the other one, let's say temperature. So from this, the low time we can use 5 and 10. Temperature like 20 degrees centigrade and 40 degrees centigrade. Okay. Then give me the table I showed. So he gave me the factor are 2, here the summary, 2 and 4. We have 12 replicates. So the run I have to do in my experiment is 12 replication with 3. So from this we have to print this design. Then after we print, let's say our parameter pH, PCD, CPC, something like that. If we have parameter response parameter, we have to fill this one, these values. Let's say from this I'll bring one of the data. If I put in case the design here, it's okay. So you know, this may after in our measurement, if these are the response results. Now we can go directly to the design of the experiment, then factorial. Now we have to go to the analysis. First, it was to go to the create. Now already we created and we collect the data. So now we have to analyze. So we can click this analysis. The response are pH and PC. We can select. So from this, we can see each what the effect parameter are time, temperature, and their interaction, how it looks like. And then option, this is also okay. SM lambda, no need to add. So we can click OK. So from here, the very important result here is this analysis of variance here. It said that the model is significant. The model is very important. So this linear, because p-value is 0.02, which means that less than 0.05. So here the optimized regression value for TPC can be calculated as this formula. And we can see the measure the Pareto chart. This is the Pareto chart. The Pareto chart said which of parameter is very significantly or strongly affected the process variables. Let's say B variable is highly affect the process or the quality, or the TPC value is highly affected by temperature, assessed by temperature. We can also check on the graph. Again, I'll show you the normal graph. What is option? Graphs, yeah. Normal here. If you see here, it's said as, you know, this, the blue color is showed as significant. You know, this parameter is significantly affected the process, and the blue are relatively not. So we have to now, during optimization of our process, when, let's say, the process is extraction, when we extract the total phenol compound of some product, so we have to focus on the temperature. So we use the temperature between 20 and 40. So we have to consider which is the optimum one. So the optimum one is calculated by the regression model that previously we have seen this. So the optimum TPSE, the best value can be given with this minus of 165 plus 26.5 times time plus this times temperature and this interaction. We can get the optimized TPC value. This is at the regression model efficiency is about 65%, I think. In pH, when we see in pH, is similar. For the pH, the model is not significant. It shows that here. The P value is 0.430. So when we see the plot also, all are non-significant. So we have to focus the optimization on the temperature for extraction of TPC, where when we think the extraction of TPC, we have to concern about the temperature. This shows that. So this is the practical aspect of design expert ANOVA. So if you have any question, welcome. For today, this is enough.
Thank you so much, Zainabu, for the nice presentation and also for the valuable information. And really, it is very useful, and really, I like it so much. For the audience and the participants, if someone has questions, please raise your hand, and maybe you can ask as you wish. You're welcome. Voila. Just open your mic. Voila. Okay. If someone has questions, just like open your mind and then try to ask. Okay, Abdullah.
Assalamu alaikum, Muhammad.
Alaikum assalam.
I have a question, but I need to say thanks for this webinar. And I'm far away from your discipline. I am civil engineer, and I applied this software before in quality control and quality assurance system for my project. I need the instructor tell the attendees about how to install the software and where we get the software. Thank you, and I will leave after 5 minutes. Thank you.
I think you can search on Google, but it's only for trial. You'll get for trial for sometimes. After that, either you have to use the old version, or you have to subscribe, or you have to both. I think these are the alternative for this software.
Okay.
But it's freely available in online. Google, you can Minitab version something for Windows. If you Google, you will get the Minitab. Let's say I will check. Okay. Free. And this side. This is the company, so download free trial. This you'll get so far. The latest version is available for trial. Maybe the old version, maybe you can access. I think the old one, but you can. This is the company.
It's free for everyone to download it from Google.
Yeah, free trial. You can.
Right. شباب، إذا في شخص عنده أي سؤال أو أي استفسار ما في مشكلة، ما يتردد، لأنه الفرصة متاحة للجميع وممكن أي زول يسأل، يعني ما في إشكال. إذا ما في إشكال، أوريدي المحاضرة مسجلة وإن شاء الله حيتم مشاركتها يعني بعدين عبر اللينك، وأي واحد ممكن عادي يعني يتابع ويراجع. بإذن الله السيشنات متواصلة يعني. For some of our colleagues, if you do have any questions, because really this chance is very nice and good, like, you know, you will have the answer right now from Zainabu. So otherwise, if it is not, we already record the lesson and we will share it with you, and you can go back again if you hesitate about everything, or if you have anything, so you can go back to the record. All right, Imad.
Hello.
Hello.
Thank you so much, Zainabu, for this faithful lectures. Also, this lecture, like it's the informative lectures, also the simple guidelines is how to use Minitab for statistical analysis. We hope this is not at the end of the webinars, but this is the beginning of the webinars in statistical analysis. But we hope like to be a series. But this is the beginning, a step, and then we can follow. So there's a step by step from the beginning to advance using Minitab. And also, just if you have any other options for the different software that a student can download it for free, we should focus on the open access softwares, because some of them they cannot buy this one. Maybe also the price of the software is high for some students. but their other software also can be open access for them. But this is a good chance just to hear about the Minitab and how to use it. For me, this is the first time I heard about the Minitab. I use other softwares, but it's a good chance to know this one. And thank you for all participants that joined us today to this webinar. And the next webinar also just be around, and then we'll share any news about this webinar in our Facebook, in the Sudanese Research Foundations, and different WhatsApp groups. Just you can see our advertisement for this lecture, and then you can join us. And if any one of you also do you have something you just need to share with us, also we are welcoming with any new idea that can help other researchers. Thank you, Nabu. Thank you, Muhammad Umar, just to lead this session today.
Thank you.
Thank you so much, Imad, for the nice word. And also, as Imad he mentioned, it is very useful software how to analyze your data. Personally, I surprised because I didn't know there are some software you can do the experimental design before everything. So Minitab can reduce the time consuming if you insert very well your factors and your treatment, and you will get the layout of the experiment very easy. Thank you, Zainabu, for this very nice background and very nice information by using Minitab. And as Imad he mentioned, the series is continue, and this is just the beginning, and we will keep continuing every week if we have free time. So yeah, and thank you for the participants who is joining us today, and hopefully we love to see you again because the series is continue with different titles and with different colleagues they will present every week. Thank you so much. Zainabu, if you have something to say, just say it, because we will gonna close.
Thank you for everything. I think this is enough for me. Thank you.
اوكي ثانك يو. شكرا لكم جميعا. المحاضره كانت ممتازه جدا صراحه للامانه، ويعني بتدي خلفيه طيبه جدا عن التحليل الاحصائي بصوره كامله باستخدام واحده من تطبيقات التحليل الاحصائي. المينيتاب يمكن يكون معظمنا ما عندنا عنه خلفيه، انا شخصيا يعني يمكن جزء من الزملاء، لكن هو تطبيق بسيط جدا، وزي ما واضح في المحاضره انه بيسهل لك كثير جدا من التفاصيل. يعني واحده من الحاجات اللي احنا بنلاقي فيها كثير جدا من اللغط اللي هي بدايه التجربه، كيف انك تعمل التجربه بطريقه صحيحه، وكيف انك تعمل كولكت للداتا. يمكن ده يختصر كثير جدا من الجهد اللي احنا بنبذله عشان ما انه نعمل سيت اب للتجربه بتاعتنا. بالاضافه لذلك المهارات بتاعت التحليل يعني بصوره بسيطه جدا جدا وسهله جدا جدا وفي المتناول كمان، يعني تفهم انت عملت شنو، وكمان بتساعدك في الكتابه بصوره اوضح، يعني ما زي التطبيقات الثانيه الدايره فهم بصوره عاليه ودايره تركيز كبير جدا جدا زي الار ستوديو والاي بي ام اس بي اس اس، لكن ما بنقول انه هو افضل منهم، لكن بنقول واحده من نظم التحليل الاحصائي ولا برامج التحليل الاحصائي بتساعد الباحثين وصغار الباحثين انه يعني يساعدوا نفسهم شويه في بحوثهم. يعني شاكرين ومقدرين والله لكل الشباب الحضور، وشاكرين ومقدرين لعماد ولزينب، وان شاء الله نلتقي مجددا في محاضرات ثانيه، وان شاء الله لو اي زول عنده مشاركه زي ما انا وعماد ممكن يتواصل، وعلى الرحب والسعه ان شاء الله. كل الود والتقدير. ممكن تكفي يا عماد بعد كده خلاص.